Okay, just a little bit more to do with synthetic division and polynomial functions. We already know how it works. This next example is just a quick way of showing that you don't have to just use it. You can use it in conjunction with other things to help factor polynomials. Sometimes it's just a good way to get started, and then it may lead to other ways to complete the factoring problem, which might be even easier. So let's look at one example here. Let's get our function out here. Okay, suppose we want to factor this thing. That's pretty messy, and we don't have any really good techniques for that. But fortunately, we know that 2 is a root. Usually you know somebody gives you that, or you may suspect, and you could test it, but we're going to take it for granted that 2 is a root. We've been given that. Okay, so rather than write x minus 2 and try to do long division here, which we could do, synthetic division is a lot easier. So we can start with synthetic division and see where that takes us. So x4, x3, x2, x, and finally the constant term. Again, draw the line, bring down the first one, multiply. 2 times 1 is 2, add them up. 2 times 3 is 6, add them up. 2 times 4 is minus 8, add them up. 2 times minus 12 is minus 24, add them up. 0, okay, so we were told it was a root, but we actually verified it. So it is a root, that's good. So right now, what do I know? I know that x minus 2 is a factor because 2 is a root. And what else do we know? We have this quotient here. Again, we reduce this by 1, so that's our x cubed now. So 1x cubed, 3x squared, minus 4x, minus 12. So synthetic division got us to there. We don't know what to do here since we need a root, so we're probably going to have to switch to factoring right now. This is 4 terms. So if you think back with 4 terms, grouping is generally something to try. So let's try it. So let's group inside here. For this first pair, they share an x squared. So that would be x plus 3 when I pull that out. Over here, they share a minus 4. And that'll be x plus 3. Got to be careful there. When I factor out a minus here, then I need a plus here so that if I multiplied that back in, it's a minus 12. Anyways, whenever you have a negative here, you always want to factor a negative out so you have positive leading term in there. All right, here's a common factor. So we can factor that out. And what does that leave? X squared minus 4. Okay, we look at that, and then we have even more factoring techniques we can use. If you recall the difference of 2 squared, difference of 2 squares is this rule here. Okay, that's what we have here. This would be like a, and this would be 2 squared here. So it's a difference of 2 squares. And it's just, they're like conjugates of each other. A plus b times a minus b. Just change the sign in the middle. So our answer is x minus 2, x plus 3, and then finally this will be x plus 2 times x minus 2 following this. X plus 2 times x minus 2. Hold on a minute. There. And there it is. Now, notice one thing, and we're going to look at this in the next section, but when the degree is, you look at the degree of the polynomial, that's the degree of the whole polynomial is the degree of the highest term. So here it's 4. You should have 4 roots. Well, if you look at the roots here, we have 2, we have 3, minus 3. We have minus 2, and then we have 2 again, but that's a repeat. So it looks like we have 3 roots, but we have 4 factors. We actually have a root that's used twice. So technically there's 4 roots, even though we would only write 3 distinct roots there. Okay, one last problem. Get my pencil working here. There we go. This last problem's interesting. How do you write a function if you're given the roots or the factors? So what we want to do here is, if I can get this pencil working. All right, here we go. Create a polynomial function given the roots. If you're given the roots, naturally you can write those as fractional pieces of this. So let's start that way. Okay. I'll do one example. Suppose I know that I have these roots. It's possible that you could see them on a graph, somebody labeled it, or they just tell you these are the roots. What is a polynomial function? Well, from the roots you can create the factors because, like here, if I multiplied all these factors together, then I would get this function. And that's what we're going to do. We're going to go backwards. We're going to start with the roots, which means we're going to be able to write the factors. And then if we just multiply the factors together, we'll get the polynomial function and we're done. So the first thing we got to do is remember you need to change the signs when you write the roots. So our function is going to equal x minus this. And again, why do we change the sign? Because the root here would be when this is 0. If x equals the square root of 5, this is 0, and that's square root of 5, so that's why you need a minus there. Next one, we're going to change the sign again. This time it's going to be x plus the square root of 5 for the factor. This factor leads to this root. And then finally x minus 4. Okay, so all you got to do now is multiply these together. You can only multiply any 2 at a time. Let's start with these. And the nice thing about starting with these is these are conjugates. They're kind of like up here. So I have this form. Now I'm going to go back this way. So it's going to be the first one squared minus the second one squared. So we're going to have first one squared minus second one squared. Square root of 5 squared is just 5. So that's done. And then we're going to multiply it by this one. All right, real quick. I had a Winans coffee show up right in the middle of this, so had to take a break on that one. All right, it's just like in class. Back to the action. The last thing to do now is multiply these together and we're done. So x squared times x squared times minus 4. Okay, then to here, minus 5 times x. And then minus 5 times minus 4. And that's our function. Okay, that's it. So 4.3, we're going to learn more ways to try and tease out roots or to test to see if certain things are roots, and also more about what roots mean.